2 molecules of G3P produced by a total of 6 turns of the cycle combined to form 1 molecule of glucose.
So
It's just referring to the fact that you have to have that ratio in order to keep the carbon count.
That makes sense then.
Yeah.
Okay, yeah.
It would be 2 of what we see here, right?
That makes sense.
Yes. So it would be 2 of what we see here, which is 6 cycles.
So it doesn't make sense. So what they're saying is, so 1 turn of the cycle technically is just 1 CO2 onto one of these, onto one of these, onto one of these, onto one of these, right? But it takes technically 3 to make 1 of these. And to make a glucose, which has 6 carbons, we'd have to go through it 6 times.
6 cycles. Yeah. Yes.
That makes sense.
Okay.
I'm glad you brought that up.
The answer.
I'm sure we went over that, but it's just so much time. What other questions? Or else I have some questions. But my questions are easy. So. Okay. This isn't as one question can be as good as it counts. Crimps. So, to make 1 glucose molecule, how many NADPHs do you need? Yep. Why? Can you answer why?
Is it because you have to go through 3 times?
How many what?
Right?
So,
How many what?
yes. So, the question was, to make 1 glucose, how many NADPHs do you need? So this technically classifies like 3 times through.
12.
Right. And so, we use 6, 3,
To make
2 in each one. And then if you go through this all, I guess you'd say again, then you'd use that. It'd be 12.
So we need 2 of these cycles, and each cycle takes 6 NADPH. Because like we said before, it's 6 cycles to make that, and the CO2s come in 1 at a time. So this represents 3 cycles. And so you would need 2 of these to make 1 glucose molecule. And so it would just be 2 of what we see here, which requires 6 NADPH. So 12.
Yeah. So that would probably be one of the most, I guess, probably the most difficult thing to understand about this, because anyone can just memorize that, but understanding that this is like the ratio to make this work, but depending on how they classify the cycle, this could just be 1 turn of the cycle if you're just doing 1 of these. The way that kind of helps me, the way that I kind of help, that I understand this, that helps me is we have, you have so many Rubiscos putting on carbon dioxides onto these, right? And then you have, at the same time, so many G3Ps. And it's not like this exact, Rubisco will put all the carbons on the same 3. One Rubisco may put a carbon on one of these, and then a Rubisco way over here may put a carbon on one of these. And then you get your 3 different ones because they just come from, they've all were synthesized, just happen to all be in this state at the same time. Okay? Now that's all kind of coming back,
Yeah, it makes sense to me.
So how do you feel? How do you feel about that? Do you feel like you at least kind of understand it a little bit better, or is there something we could hit a little more? Be honest.
Well, how much Rubisco is going through? Is it just like 1?
So Rubisco is just an enzyme. So in this, you have this huge pool of carbon dioxide, let's say, and you have this huge pool of just ribulose, and you just have so many Rubiscos that are just
Just coming in.
They're just in there and they're just throwing carbon dioxides on.
Okay.
So it's not like a ratio. It's just you have so many. So you make like 50 cookies, but it's not to say you're 1 per 50 cookies type
Right.
things.
Yeah, okay.
Cookies sound really good. So that is the Calvin cycle, guys. Here's a good thing to know. Everything, all the ATP, all the NADPHs that are produced during this light reaction phase, okay, those all power the Calvin cycle. They're not used to go help do something else, okay? They're only used as inputs into here in the Calvin cycle to make it work, okay? So that's just a good thing to know.